Alright, so I have 4x squared minus 4x minus 3. And today I want to teach you guys a concept called chunking. Sounds like trick-or-treating. Chunking. What is chunking? Chunking is a substitution. Or another way of saying it is chunking is the greatest common factor of the first two terms. Chunking, you'll see, is a substitution, and it's really a greatest common factor of the first two terms. So I'm going to divide my work here to give us some space, and I'm going to show you guys how to do this problem really in two ways. So the first one is chunking. If you look at the problem there, you'll realize there is no greatest common factor, because I have an even, and an odd. But if I apply chunking, put your finger on the first two terms. Partner A till partner B, what is your GCF of the first two terms? Ready, set, go. Okay, so you guys recognize they both have a what? A 4x. Now be careful now. If I look at these two, I recognize that yes, 4x is probably the greatest common factor. But what I need to do is I need to think of a shape. My favorite shape is a square. And what I want to do is I basically want to put something in here to get 4x squared. What do you think I can put in there? 2x. So there is my substitution. So we're going to put in 2x. Look here, watch. So 2x, that means 2x times 2x is 4x squared. And then if I do a minus 2, and I chose minus 2 because now I can do negative 2 times 2x equals negative 4x, and then I have the minus 3. So I'm saying that this expression is equal to this expression. And here comes my substitution. Instead of writing 2x, what are we going to write? We got a box squared minus 2 times a box minus 3. And you might be asking why we went from now letters to shapes. Essentially what we're doing here is we are making the quadratic problem, we're getting rid of the a value. Do you see that? And why I did that now is so that I can actually just do my x method. Let's review the x method. Now I'm doing it from right here. A times c, what's my a value, class? 1. And your c value? Negative 3. So a times c is negative 3. What letter goes down here? The b value. What's your b value? Negative 2. Partner A, whisper to partner B, what are the two numbers that go there? What are your two numbers that go there?
Negative 3 and 1.
Juan, what are your two numbers? Negative 3 and 1. So I have a box. We have negative 3. 1 here is positive. And then I'm going to do my substitution one more time. And so basically what we have now is 2x minus 3 and 2x plus 1. Okay, they're going to ask you to do three things in a problem like this. So I'm just trying to give you an extra example. They're going to tell you to chunk or factoring, basically to factor it. Same thing we did yesterday, identify the 0, which we're going to do right now, and then we're also going to make a sketch. So, partner A tell partner B, how do you go from factoring, that's the first big idea, let's write a 1 over here. How do you identify zeros, or how do you solve? Talk to your partner, 20 seconds. Trisha, we just factored. How do you solve? There you are. How do you solve? How do you identify the zeros? Equal it to 0. Let's do that. 2x, I should know here. 2x minus 3 equals 0. And 2x plus 1 equals 0. I'm going to do the opposite of the order of operations. So I'm going to do 2x equals 3. Now, why did I say the opposite of order of operations? I did see some students try to divide first. That would have been incorrect. And then now, lastly, we're going to divide. So x equals 3 halves, or 1.5. And then I'm going to do the same thing over here. I'm going to subtract 1. So I get 2x equals negative 1. And divide by 2. You're going to get x equals negative 1/2. Or if you put that into your calculator, if you get this on your calculator like I just got, 1/2, you have this thing called S to D, or DS, just press it, and it gives you the decimal, so 0.5, so negative 0.5. So we factored it, we found the zeros, and now I'm going to graph it. Graph should be pretty simple. I have 1.5, $1.50. That's on the positive side. I have 50 cents. It is on the negative side. I have a y-intercept of negative 3. This should help you reinforce that it's going to be opening up. My a value is positive. Remember, the y-intercept in this case is not your minimum. And your graph looks like this. Okay? So factor, solve, and graph. Now you might look at a problem like this and you eventually might say, Mr. Ng, I don't know when to use chunking method. Well, here's the wonderful thing. You don't have to chunk. You can do something we've done before called Xbox. So, now I'm going to give you and your partner 4 minutes to fill out both the X and the box. And when you fill out the box, I want the inside and the outside of the box. And then you're going to put your answer in there. Okay? So go ahead and take 4 minutes to do that. Same problem. Clarify any questions you guys have and do the same problem. Ready, set, go. Alright, Leslie P. If I looked at this, what is your A value? B value? Positive or negative? And C value. What 2 letters go on the top there, Leslie P? So A times C. And what is 4 times negative 3? I'm sorry? So you're doing A times C. A times C. Which is? Negative 12. And that's the P or B value? Negative 4. Partner A, tell partner B the two numbers you put in there. Fania, what is your two numbers? Where are you sitting? There you are. Negative 6 and 2. Class, show me your thumbs, yes or no. Can I put in negative 6 and 2 here? Okay, the answer is no. Remember, A value is greater than 1. So you have to use both the X and the box. The shortcut is when this number is equal to 1, then you just do the X. If you are confused, just keep doing X box. If this is 1, do X box. If this is 10, do X box. Okay? So you cannot go from here to there because in this problem A is greater than 1. Let's pretend you've never seen this before, so let's review it again. Nathan, what always goes into the top left of the box? Yeah. So in this case, so that'll be the 4x squared. So let's write that. Nathan, what always goes in pink here? Correct. These two values. Remember, these two values are splitting the middle term, so we have to add an x. Do you see that? So essentially, this is negative 6x, this is a 2x, so this is negative 6x, and this is 2x. And Nathan, what always goes in the bottom right? Good job. Sade, help us figure out what goes on the outside of the box. You said 2x squared? On the top, 2x? And over here? Okay, so you're thinking if you put, what did you want to write there? Sorry. 2. Okay, so if you put 2x squared here, right? That means 2x squared times something only equals negative 6x. Do you see that? So that means that you can't have a squared here. This one has to be an x. Does that make sense? Sade, can you continue? Positive or negative? And over here. Something times 2x equals 2x. Yeah, 1. So I'm going to have 2x minus 3, 2x plus 1. Raise your hand if you got that. Good. And what did you guys recognize if you no chunk but x box? Your answer is the same. What does that mean? Do you have to use the chunking method? No, only if it makes more sense to you.